Good evening, everybody. I'm tired. I'm not gonna lie, I'm not gonna have the same energy on this one, but I promised that I was gonna show the Flash program process when I got it finished, and it's finished ish. It's not all the way where I want it to be, and I have been down some crazy rabbit holes, and hopefully, sharing it will help prevent you from going down some of those same dead ends and bug riddled paths that I went down to end up where I'm finally at, which is a place where I feel really good about as far as programming and flashing the devices for production. And so, excuse me. So let's talk about it. I actually made a draw IO to share. And it kills me that I'm not going to do like a full polished video on this. I do have some notes written down because I would love to do a blog post because this entire process was crazy to construct, but I feel like it's, like I said, it's not all the way there yet, but I feel like I'm getting to the automation and high and tight place where I want to be regarding getting all this stuff working. So let me open existing diagram. Okay, I'll show you this in a second. Before I do that, I want to give just a little bit of background for anybody that may be new. So we've got our devices here that have an ESP32 inside of them. It's got an e-paper display in it. And I'm shipping these to customers. I actually just sent a few out today. Hopefully going to start ramping up and shipping more and assembling more. Maybe I'll show that in a video if I get the time. But I want to be able to program these in a way that is repeatable and very quick and error-free. And the way I did this before with our Puck product was I was hand programming them with a Raspberry Pi. I really like the Raspberry Pi for doing that. It's separate from my development machine, and it kind of creates an environment that if I need to, I can scale. Like if I need one or two more of these programming devices to scale up, it's not like I need a full laptop or anything. Just a Raspberry Pi will do the trick. And so I really like that process. I also like that it's not on my development machine so that I don't make the mistake of, and I would make it, like it's not a matter of if, it's a matter of when, pushing a development branch of code onto a customer device and sending it out because I wasn't paying attention or I got, just there's a lot going on, and the less we can, the more we can limit those mistakes, the better. And so my grand vision for this was it would be cool to have a Docker image that was everything that I needed to be able to program and flash the ESP32 that's inside of this device. And that way, all I would need to do is pull the image and run a command, and it would flash it, and done. Nothing to worry about. And so I finally got this to a place where I'm pretty pleased with it. And so let me show you a diagram of it. It's a very not great diagram, but it'll get the job done. Make sure everything's good here without drop frames or anything. Okay, I think we're doing good. All right, let's zoom a little bit. Yeah, like that. Oh, let me get it away from my image down in the corner. We can go one more. There we go. Okay. All right, so this is what I ended up with. And so let's talk through it. So I had heard about GitHub Actions before, hadn't really checked it out, decided to check it out. I'm in love. They're amazing. And to me, it's like the future of CI CD for the projects that I'll be working on. I know there's lots of other things. I use Jenkins at work. It's okay. The GitHub Actions so far that I've seen and had a little bit to play around with is like blows my mind. Like I'm into it. And so that's how I got the workflow going. And I feel like it's, I pay $4 a month. I have I think that's like the pro subscription. It's like virtually nothing. And you get 3,000 hours of GitHub Action runtime as part of that $4, which if you think about, that's the time spent running in the actions machines that I'll talk about here in a minute. But if you think about that, like the free tier of like EC2 in Amazon is a month is about 750 hours. So you get 3,000 hours of GitHub action time a month for $4. Like, I don't know if it'll always be that way, but for now, like that's way more than I would ever need. So let me talk about the setup here. And so this is what it ended up looking like. So I have my code on GitHub. That's where I keep my repository. That's symbolized by this over here, this source repo. And inside of that, there's 3 files really that matter for our purposes. Obviously, there's all my firmware source code in this repo that does everything that the device needs to do. But the things I added to enable this workflow were a Docker file, a GitHub action workflow, YAML file, and this program.sh is just the bash script that does the programming, which gets built into the Docker image. And so the way that this works and the way that I've set it up is whenever I create a new release in GitHub, and this is where I'm trying to limit errors in the process and get rid of I don't really want to be building production firmware on my machine. I was going to look into having it built through some other CI framework, but I will look no further. For now, GitHub Actions is it. So I have set it up so that, and I'll show all these files here in a minute. In the GitHub Action workflow file, you define when you want the action to run. And the way I've set this up is to run on a published release. So anytime I publish a release on my repo, this action will run. And what it will do is GitHub will spin up this GitHub Actions runner. And basically, I believe it's a Docker container itself. I don't know if that's entirely, I think it is though. And it just runs actions for you. And there's actions for everything. Anything you can think of to do in like a CI/CD pipeline, like somebody's already built a GitHub action for it, and you can basically reuse it. In my case, what it does is it builds an image for my Raspberry Pi, and it puts it into an ECR repository. That's over on AWS. I have free credits there due to the like startup businessy offering thing, and so it's a free place for me to store the images for now. You could just as easily have GitHub Actions put it to Docker Hub if that's where you want it, or some other container repository that you like to use. And so at the end of that, it builds that, puts it in the ECR repository. I have an AMD 64 image and an ARM v7 image so that I can actually pull it down on my a regular machine to use to program and flash devices, or use it on the Raspberry Pi. We do that with multi-architecture, BuildX. Like I went into like so many things. I had my learning overload in the last week. The end result of the action is I get these 2 images, and then all I have to do, I say all I have to do, you'll see how that's not entirely true here in a minute. What is now that I figured everything out? All I have to do at that point is pull the image onto the Raspberry Pi, plug in a device, run a single line, and it will flash the device with the firmware release from that version that I tagged in the GitHub release. So there's like no human error involved other than the bugs that I create in the firmware. But I'm never going to accidentally like get a program of firmware onto a device that was some dirty branch that I was working on, dev branch. Like it's baked into the image, and that's how we're flashing the devices. So this is, again, not a great graph, but it kind of gives you an idea of it. I guess I could have drawn like a Raspberry Pi over here that pulls this ARM v7 image, and what it does is runs this program.sh inside of the container to flash the device. So let's get rid of this and let's look at all these files. And I'll tell you the pitfalls that I ran into along the way. So let's first of all look at if I were giving advice for somebody else doing this, I went about this the wrong way. We need draw IO back. Open existing. Let's bring this back over here. Okay. So let's bring this. The way I started doing this is I was messing around with like the repository over here in the GitHub Actions and working my way, not really from top right to bottom left, but like I was kind of working up here down. And that's not the right approach. The right approach is, first and foremost, get the script that you want to run working. And you can even dev that on the Raspberry Pi if you want. And I wasn't. I was deving it on my local machine, which created some issues. But basically, you want to create that script that's going to program and flash your devices and do whatever else you need done first. Which I did a few streams ago, but then I started focusing on the GitHub Actions and got all jumbled around. Get this working, doing exactly what you want, and then work your way up the chain. And so this might seem familiar if you've been watching the stream. This is just the very simple bash script. You can see it's only 37 lines here. And the things that we did before, like we're running FTX prog to program the FTDI chip to be in the state that we want it to be in. We validate that. And then I'll explain this in a minute, but I'm printing out the version.txt. This is the file that's a part of the repo. So I know that from the code that's checked in to my main branch, this is the version that I'm about to program flash onto a device. And then I'm just using ESP to flash all of the different partitions. I did... Ecr, who I found out through a GitHub issue, I believe his name is Ivan, tipped me off to using flash args, which is really cool. In the build folder here, let's just take a look really quick. So this is the build folder. If we come down here, there's this flash args file that the build process creates that are the flash arguments. And so right now I have mine where I'm like hard coding like these addresses in. I basically am recreating the flash args in my script here. And so there is a way to just pass esp-tool the flash args. It would require me to do the whole build folder, so I'm not doing that for now. I'm gonna, like, how I have it for now is how I'm gonna leave it. But you can use this flash args with esp-tool, and then you don't have to program it into your script. And so I'm just using esp-tool. And that's it. This programs and flashes my devices. Now, I could take this and run it on a Raspberry Pi, and as long as everything was in the folder where it's expected to be, it will flash a device. And so what I wanted to do was create, like I said, a Docker image that contains this script so that it can be run inside the Docker image. All the dependencies are there. I don't have to worry about installing esp-tool on the Pi or making sure versions are correct and this or that. It's all wrapped up in an image and pulled down and run. So that is probably the easiest part of all this, is making that. The next thing that we needed was the Docker file. So we need something to create our image from. Now, this is where I ran into a bunch of issues, and I'm going to save, hopefully, somebody a bunch of time. I'm not going to go over like the anatomy of a Docker file. If you're not familiar with it, do some research, do some Google searches. I highly recommend it. I love Docker. And so I'll just skim over some of this. If you don't know the terminology, don't worry about it. The first thing that you have to do is choose like what you're going to base your image on. You have to use a from line. And I'll come back to that because that was the big problem. And then all I needed to do was install the things that I need, build essential GCC make so that I can build FTX prog. Again, I want to just embed this in the image so that you don't have to have FTX prog built on the Raspberry Pi. It's just included. And so I do that, I build it. This is a multi-stage Docker build. So the output of this one is the FTX prog executable. And then I do another from, so this is the second stage. I do a copy from the first stage, 0, the FTX prog executable, and I copy it into the FTX prog directory in the final image. And then I install Python 3 and Python 3 pip, libftdidev. Libftdidev is needed for FTX prog to run because it dynamically loads that library. And then I pip3 install esp-tool. After that, this is the add star.sh into tools. Right now, it's just program device.sh. So this is what bakes that script into the image. And then I do this add binaries release. And so you can see binaries doesn't exist here. So we'll talk about that in a minute. It will in the CI environment. and then I set the workdir to tools. I don't really know why. That's so I can run the script without changing directories. That's why, because I put that in the tools directory. So that's it. That's all the Docker file is. Pretty simple. What I originally did, and this is where I'm hoping to save somebody time, is I was using from esp-idf the version that I'm using, like IDF version 4.3.1, 4.1.3, whatever I'm building my firmware in currently, is what I was using. I was using the official image. Well, that official image from Espressif is 3.2 gigabytes. It's huge, and it does have ESP-tool in it, but I was running into a load of issues doing that when all I really needed is ESP-tool. And since you can pip install ESP-tool, I took this approach instead of just using a slim version of Debian, so that the container, at this point, the image size is down to, I want to say 340 something. We'll look at it in a minute. But considerably smaller than 3.2 gigs. So you do not need, I got off the, I was out in left field on that, trying to use the Espressif container for some reason because it had ESP-tool built in. And so an alternative is just to satisfy that dependency yourself and just install ESP-tool through pip. This is the key. Buster. Buster is not the current Debian. Bullseye is the current Debian. And so I spent probably 5 to 6 hours trying to get this to work using from Debian Bullseye Slim. And after, like I said, 5 or 6 hours, I found out that there is a gigantic bug that makes none of this work. Like there's like a kernel date time thing. There's some weird thing. I didn't fully nail it all the way down, but and it's a known issue, but it's not it's not super well documented. But like pip install wasn't working. I was getting like an extract tar error. I was getting missing, what was it? Like GPG certificate errors trying to do the app update. If you just do a from Debian Bullseye Slim and then try to run app update, it will fail. And so that, again, save me 5 or 6 hours, save you 5 or 6 hours. At this point, as of the creation of this video, September 28th, 2021, you want to stick with Buster. It's the previous version. Bullseye has some issues. Somebody seemed to suggest it might be a Linux kernel 4 to 5, and I didn't look more into that. But anyway, Buster Slim here is important. Bullseye Slim is going to waste your time. All right, so that's it. That's how we build the image. Now, this happens on GitHub. And let me show you how that works. So again, now I can run this locally. Like I could do a Docker build and it will build this just fine. But then I need to do something with the image and it's not automated and I'm doing manual steps that I have to remember and not screw up. And we don't want to do that. The whole point of CI is, or CD, I guess it would be in this case, so that you don't have to think about it and it does it for you, so there's no human mistakes. And that's where GitHub Actions come in. So let's look at this create programming image YAML. And again, this isn't going to be a GitHub Actions tutorial. I'm just going to show you. It's not very complicated. It's 73 lines, but there's a learning curve to get to those 73 lines. But let's go through it and see what happens here. So in a GitHub action, you give it a name. So create programming image. That's what it will show up on the UI, and I'll show that in a minute. And then you have an on, and this is your trigger for when to run this action. And workflow dispatch is so that I can manually launch it from within the GitHub UI. I may or may not remove this because this should only run when a release is published, which is what these lines do. It says when a release types published. There's release types created, deleted. Like there is a GitHub action for any action that you can take on a GitHub repository for issues. And I mean, just anything you can think of or do within the UI of GitHub, there's an action that you can, like, there's a syntax to trigger an action based on that. And so the one that we really want is this release types published. There's also a release type of created. And as somebody pointed out, that will happen even when you create like pre-release or draft releases. And so I don't want to run it for that. I only want this to run when I've actually published a release and say, this is the next release of the firmware. And so that is what will trigger our workflow, is what it's called. And within the workflow, we have these jobs. And the jobs will run in parallel by default unless you specify otherwise. And then in each job, we give it a name. So I have this build firmware assets job. And then if I scroll down, I also have this build and push Docker images job. So this workflow consists of 2 jobs. And then each job has a bunch of steps. And we'll list those out here. But you can see right here, I have needs on my second job, needs build firmware assets, which is the name of this one. That makes them run in series. So the second one won't run until the first one is done, which in this case has to happen because the first step is actually creating the firmware artifacts from my source code. And so I can't build a Docker image with those baked in unless I built them first. So now, again, I don't want to turn this into a GitHub Actions thing, but you kind of have to know some of the terminology. Under the steps, you can use, anybody can create a GitHub action and put it to a repo, and you can reference that. There's so many ways to reference actions. There's built-in ones like this actions checkout at v2. But you can also point to other people's repos. You can point to third parties. Like there's just, again, anything you want to do, somebody's created an action for it. And so I'll just walk through what's happening without explaining like how GitHub Actions works. Maybe that's the way we'll do it. Okay, so the first thing we're going to do is we need to specify runs on. We're going to say that this job runs on Ubuntu latest. You have Ubuntu, you have Mac, and you have Windows. So you can run on all the 3 major platforms depending on what you need to do in your job. The steps, the first thing I'm going to do is check out the repository. And so all we have to do is say actions checkout at v2 with submodules true, which is going to do a recursive checkout of the repo that this action lives in into the runner context. So again, we don't have to specify anything else. We just say actions checkout v2, and in that runner, in that instance that's running for you on GitHub, the first thing it's going to do is check out the source code from my firmware repository and put it in the local context. The next thing I'm going to say is I want to build the binary assets. Now that I've checked out the code, let's build it. And this is where it gets really incredibly powerful. All I have to do is say uses Docker and then say I want to use the esp-idf version 4.3.1. So I am locking in the esp-idf version that I want to build my firmware with. And so it will say, great. It will use this Docker image. I mean, there's so much that's happening for you here. It's amazing. It's going to put my source code into it, and then all I have to pass to it is idf-py build. And it already has my source code because I checked it out up here in the first step. And it's going to use this environment, and then within that environment, I have idf-py, so I just say build. The end. It's going to build everything out. It's going to create just a build folder just like I have here on my local machine. It's going to create all these folders that you see over here in my build folder. Well, at that point, I want to create what's called an artifact in GitHub Actions, which is from this job, I want to take a bunch of files out of it and kind of store them away so that other jobs can reference them. And so in this case, I'm building these binaries, but I might want to do a bunch of things with the binaries. In the future, I've got deploy the fleet where I keep all of these things for the devices to get. I might want to use those binaries to automatically create a new release and deploy the fleet so that the devices get it. Like there's a lot of things you can do. So I separated this out into its own job of just creating the build assets and creating a GitHub artifact with them. And so again, all we have to do for that is just use this built-in action called upload artifact. This at v2 is the version, so you can lock in the version of it. And then you give it a name, release binaries. And I just specify what files I need. And here they are. Bootloader bin, I need the partition table, I need the OTA data initial, I need my stat feeder firmware, the storage bin, which is the spiffs partition, and then I use version.txt as well so that I know which version of the firmware this is. If no files found error, that is like if for whatever reason the build failed and none of these things exist, there's an error and we need to stop. Retention days. So these can be available in GitHub for as many days as I want. I think the default might be 60 days or 30 days. I don't need them to stay very long because I'm going to immediately turn around and bake them into an image. And so for now, I don't need those to stick around and use up storage space in my GitHub account. So I just have the retention days set to 1. So after a day, it'll get rid of it. And I'll show you what that looks like here in a minute. All right. Now that we've done that, we built all of the firmware. We've created what GitHub refers to as an artifact, and those files are sitting there. And so the next job is build and push Docker images. I want to point out really quick, there is nothing multi-architecture about this Docker file. There's nothing AMD64 about it. There's nothing ARM about it. It's just do these things. However, if I were to build this Docker image on my laptop here, which is an AMD64, and then try and just copy it over and run it on my Raspberry Pi, that's not going to work. The architectures don't match. No, Docker's going to give you an error. So just want to point that out. All right. So same thing. We're going to run this checkout action, which gets the source code again, why do I do that? I'm not sure if I need to actually do that. I'll have to think about that. I don't know if I actually need to check out the code here. I do this download artifact. So again, it's a built-in action. And remember up here, I called the upload artifact. I gave it a name of release binaries. So all I'm doing is saying, yeah, grab the release binaries artifact that I created and store it in docker/binaries. Again, back over here, we've got add binaries. Binaries has to be in the context of the Docker folder. And so that's why I chose to put it there. So now that it pulls that down and unpacks it right in the Docker context for the steps below here. Now, since I'm using ECR, I need to configure my AWS credentials. And guess what? Amazon has created a third-party action for it. AWS Actions and configure AWS credentials. And then all you have to do is provide it the access key ID and secret access key, which you can store in secrets in the GitHub UI. So these are just stored as these values in my GitHub repository. It pulls those and logs into Amazon ECR. It gets them ready. And then we use another AWS actions called Amazon ECR Login, which uses these credentials. That's going to log me in so that I can push repositories to it, push images to it, sorry. And then here is the Docker sauce, these next few steps. We want to use BuildX. And the reason we want to use BuildX is because it has multi-architecture image support out of the box. And so the way that Docker recommends to do that now is to use, here yet again, another third-party GitHub action that's Docker setup Kimu action. I think that's how you pronounce it. Because this is a prerequisite for using BuildX. And then we're going to set up Docker BuildX, which again, we're just using, a lot of this is copy pasta. It's important to understand what's happening though. And then we're going to build it. And so the way we're going to do that is we're going to say, we're going to reference a GitHub Actions variable here, steps.login ECR, and that is the ID. So if we highlight that, you can see, oh, look, login ECR. So from that steps, login ECR, the outputs, so after we log in, the output of this will contain a value called registry, which is our ECR registry within Amazon where our images will go. And then the repository that I want to store that in is called statfeeder, stop hovering there, statfeeder device programming. And then the image tag is going to be the github.event release.tagname. These are just, you have to look up in GitHub Actions documentation the contexts that are available. But this is where, when I create a release within GitHub and then this action runs, whatever I called it, version 1.0.2, it's going to tag the image with that. So when I pull it from Docker, I can specifically pull Docker images to flash devices for very specific firmware versions. When I run this in standalone mode, by triggering it in the UI, there's no tag name because there's no release. And so I just say, if there's not a tag name, just call it latest. And I'll eventually change this so that it tags it both. When there is a release tag name, I want to tag it with the tag name as well as latest, but I'll get to that later. So those that just creates those environment variables. And then we call run. The run is basically just like shell commands that you want to run. And so I want to cd into the Docker folder. And again, it's because of, that's why I do the checkout. Duh. Because we checked out the code, this same directory structure that exists locally exists now in this GitHub action runner. And so I want to cd into my Docker folder because that's where my context is. And then I'm just going to run this single Docker command, docker build x build. The -- push says when you're done building, push it up to whatever repository we're working with, which is specified over here. And then this is the secret sauce for multi-architecture. This -- platform, I want to build it for both Linux ARM v7, which is what my Raspberry Pi is running, and Linux AMD 64. You could also build these for Windows. I believe the Mac one will run the Linux AMD 64, but there's a bunch of platforms that you can specify. These happen to be the two that I care about. And so it will handle creating your manifest, your Docker manifest, which lists your architecture variants, and push it to Amazon ECR. And like I said, that could be Docker Hub, or that could be your other favorite place to host containers. And then the period at the end is the context, which is the current folder. And then this was actually copy pasta. I actually don't even know what this line of code does. Set output name equals image. I don't know. That's it. All of this runs, takes about, 8 minutes. And let's switch over to what it looks like. So I'm in my StatFeeder firmware repository here. And if you just come to the Actions tab, it'll show you all of the workflows that you've created. Now, I did find, I think it's a little bit of a bug in GitHub, which is the workflow does not show up until you've created it on your main or master branch, but you can run it in feature branches. So like if I were to say, let me look at this create programming image workflow, because I have, you can see I have this run workflow. That is because right up here, I have this workflow dispatch. If you don't have workflow dispatch, this option does not show up. It will only run based on the trigger that you set. And so like it says, this workflow has a workflow dispatch event trigger, and then it says run workflow. And now it'll let me choose the branch. But if it only exists, if the workflow only exists on a branch, it does not show up here. And again, I think that's maybe a bug. But I can choose, because I've been working on this actions branch. And then you can just run the workflow, kick it off, and it will run. And now you can see I've got successful runs. Let's look at one that I ran a couple of days ago. You can see down here this artifacts. Remember, I upload the binaries once they're done. And you can see it's called release binaries. You can see that it says expired. This artifact has expired and you can no longer download it. Before it expires, you can just click on it right from here and download all those binaries. So if you want to inspect it and make sure everything looks right, you can do that. But again, since I have the retention period set to a day, those expire because you do have to pay for storage and stuff. And I don't want to, so that's why I have it set that way. So let's come back and let's look at one of the runs. If you click on it, again, it shows that, but it also shows, just like any CI/CD tool, it'll show you kind of like the build stages. And because I have them running sequentially, they look like this. It'll tell you like how long it took, 12 minutes. Billable time was 10 minutes. Remember, back to the beginning, I was saying for my $4 a month, I get 3,000 billable time hours. And so I use 10 minutes of it. I mean, I'm never going to, I shouldn't say never, but like I'm a long, long ways out. I could run all kinds. I guess the point I'm trying to make is you don't have to be super careful, even in a low pay tier. You can be running all sorts of unit tests or integration tests, and there is a bunch of stuff that they can do to like set up full Docker Compose environments to like run complicated integration tests. You can run them for hours, and it'll take care of all of it for you. So you come into each of these, again, jobs. These are the two separate jobs that we set up. The build firmware assets, you just come in here and you can see every single step is lined up. So if I go build binary assets, like it'll show, excuse me, like this is the output that you see when you build it within VS Code. And just here's all the stuff, and it'll show you every single file that it built, and it'll show you any warnings. I mean, it's the build output. So and it goes through all of that, and then you can look at the next one, build and push Docker images. It'll show all the steps that it went through there. And so, anyway, like I said, I am really, really impressed with GitHub Actions, and I feel like it's still early. Like I think GitHub Actions have only been around for like a year, maybe 2 years. But it does, like I said, everything I needed to do and then some, and I love where I've ended up. And so my voice is getting tired from talking so much. Where we ended up at the end of the day. Oh, yeah, so let's show that. So the flow for me now is I'm in here and I'm going to say it's time to do a new version. It's time to do 0.1.5. I'll do that. I'll make any code changes. I will push that. If it's ready for release, I only rev the version when I'm ready to release, which I should be better about doing incrementally in between there. But I'll push the code up to GitHub. I will come into, so I'll make the changes, and then I'll come into GitHub, and I can come to code, I guess, and then come to create a new release. And then right here, I will give it a tag. I would actually do create a new tag. So I would give it, v0.1.5. I would give it the target branch to build it from, give it a title, give it some notes. And then as soon as I hit publish release, assuming that I don't check this as a pre-release, because if it's a pre-release, it won't do that publish trigger. As soon as I hit publish release, or I could save it as a draft and then publish it later, it's going to kick off this process. And 12 to 15 minutes later, I'm going to have an image that's ready to pull down to my Raspberry Pi to flash my devices. So that's sort of the flow that I'll go through when it's time to push new code. What else did I want to cover from that? I think that's it. Now let's look at what you would do from the Raspberry Pi side. So let's... I am SSH'd into my Raspberry Pi here. And so on your Raspberry Pi, you need a few things. And this is another spot where I ran into a bunch of learning curve stuff, but ended up working it. And I think this would be a little easier on the Pi 4. I'm running a Pi 3. So if I do this uname-m, I think it is. This is where I got that ARM v7L. Like that's how I knew how to use the Linux ARM v7 for my multi-architecture build. But you're going to have to install Docker, which is, there's lots of documentation on how to install Docker on the Raspberry Pi. And if I do Docker images, you'll see I have pulled this image, StatFeeder device programming, and it is 374 megs. And so that is ready to go to flash a device. Now, to pull that, you have to authenticate to ECR. And so the way I did that was I pip installed AWS, the AWS command line utilities, so that I can just use the AWS command line approaches to authenticating to ECR, because otherwise the pool will fail. That's if you have a private. So my ECR repository is private. You can make the ECR repository public so that there's no credentials. You just pull it like anything that's available on public, like Docker Hub. So, right. Let's clear that. And then all I need to do, it's probably go through a bunch here. Might be a little ways back. I don't want to have to remember that's the Docker pool. Here we go. Yeah, that's it. Okay. Once I've got the image, all I have to do, so I need Docker on my Pi. I need the AWS command line utilities so I can authenticate. You wouldn't need that if your repository is public on AWS or if you're using Docker Hub, whatever it may be. And so with just that, all I have to do is run this line. Docker run, TI means it's interactive and show the output. Remove it when I'm done. Pass in dev tty USB 0. I want to do privileged so it can access the USB device. This is my image from ECR. And then I want to just run, because I made the work dir tools, I just do /program device.sh, and that's it. And so let's, I don't have one. I don't have one lying around that I have to dig one out. That's it. I run this, and essentially all it's doing is running this script, which programs the FTDI chip and then uses ESP-tool to flash the ESP32. And then it's ready. That only took 42 minutes to explain. I feel like given the time it took me to walk through all that, it seems super complicated. And it was. Like, it was really hard to get from idea to where I am today. But where I am today is exactly where I wanted to be, which is make a code change, push it to my source control, publish a release, and then I can just pull latest on the Raspberry Pi, any Raspberry Pi that I have set up. So again, thinking into the future, maybe I need two of these like running at the same time. I need two people programming devices to keep up. I don't know. That's the hope, right? I don't have to worry about like, oh, what kind of computer do you have? Like, let me get you set up. Like, it's like nothing. Here's your Raspberry Pi. It's running Raspbian. And here's a script that will authenticate you to ECR using credentials that I created for you. It will pull the Docker image, and all you have to do is run the script. I would put that Docker command in the script so you didn't have to remember that. That's just like program device, and it runs that Docker command, and done. That's it. And it'll tell you when it's finished. You unplug it, set it here, and plug in another device. You can go from nothing to flashing devices in less than 10 minutes. And I don't have to give anybody the source code. And so I'm not worried about, eventually I want to push this maybe out to a factory to say, hey, before you even send the devices to me, go through this process. I don't really want, for intellectual property reasons, I don't want to share that with them. I don't have to. It's all baked into the image. Follow these steps and it'll flash the devices. So it was complicated to get here, but I feel like this is the level of automation that I want to get with every part of this, because for the last couple of minutes, I'll share some personal philosophy about this. Like, having worked in corporate America for a long time, the amount of waste, Bellum, I am still alive. Thanks for joining. I'm sorry I haven't streamed very often. The amount of waste that exists, and jobs for the sake of jobs, and the amount of technical debt that builds up over time that just becomes this massive weight on everybody. And so it's impossible to do anything because it takes somebody's full-time job to just get some new station set up for programming devices. Like, I'm convinced that it happens like death by a thousand cuts, that like, oh yeah, let's just like hack it all together and it'll be this crazy Wild West show. And then once we make it, like, we'll clean it up and we'll make it all high and tight. That day never comes. Like, I have worked at a company that I was right at the end of like the startup phase where it was starting to transition into big company. You never go back. Because at that point, you've got the budget to hire more people. Like if you feel the pain of like, we can't do it because it's so hard to make the changes, you just hire more people. And like, I hate that. And I think it creates this just massive bloat, technical bloat, like HR bloat of like people, when if you just spend some time up front to say like, how can I get this super high and tight and automated so that nobody has to really think about it? That's what I would prefer. And that's what I'm trying to do here, where again, I don't have to think about anything other than writing the code. I mean, for a week, I had to think about this really hard and spend a lot of trial and error and go through all these bugs and things that I found. But now that I'm through that, like I spent a week doing that, like I took the time, that week would be spent by somebody over and over and over and over if I never automated it and fixed it. And I think that's the point I'm trying to make. I spent the week, which felt like a huge, like it was really gnawing at me. Like, how much time am I wasting? I'm wasting time. I'm wasting time. I don't have time for this. I got to get these things shipped. Like, just good enough is good enough. But now that I've spent the week and I've got it not totally where I want it, but really close to where I want it, now I don't have to spend that week anymore. Now I just write firmware, push it, everything's ready to be programmed. And I don't have to stress about like, do I have the right version of this or that or whatever? It's just, do I have the Docker container that's tagged with the version that I just finished writing firmware code for? Yes, I'm ready to program devices. I could give it to one of my kids. Hey, just run this command over and over and plug in devices. Like that's all you got to do. And so maybe that's just me justifying all the time I spent, but I feel like I'm in a much better place. Again, now I don't have the burden of having to maintain that. All I have to do is maintain this process as I go through. Yeah, Bellum, don't quote me on the child labor quote. They're all legally employable age. I would never do that. But yeah, so I think, like I said, I think I'm in a good spot, at least for now. There's more things I'd like to do with this. And now that I know what I can do with GitHub Actions, like I want to GitHub Action everything. Unit tests and just integration tests. I want to pull it in on my other repository. So, I mean, I've got deploy the fleet, which is a repository. I've got the stat feeder firmware, which is a repository. I've got the stat feeder backend, which is a repository. What else do I have? I feel like there's one more repository in there that I'm missing, but like all of these could benefit from some CI/CD, and at least for now, GitHub Actions is where I'm headed with all of that. Huge fan. So, all right, that's 47 minutes. Bellum, thanks for stopping by. Really appreciate it and for saying hi. Sorry I haven't been great at streaming. I'm trying to find time, but it's just so busy. So crazy busy. So that's going to do it for the stream. If you have questions about any part of this, like I said, I would love to sit down and spend 5 hours writing like a super thorough write-up of everything I had to do to get to this, because I think I could save people, a week of time in a 20-minute blog post read that just has all the steps. I just don't have time to do that right now. But I do want to help if people need it and watch the stream. If you have questions about any part of this, because I'm sure I didn't do a great job of explaining it, feel free to reach out. Reach out in the Discord if you're not in there. I try to respond to everybody that reaches out in there. Happy to try and answer any questions about this. And I'll keep you posted on how it evolves over time. But like I said, right now, I think it's in a great spot. Using Docker the way I wanted. Everything's building automatically. No human intervention other than just writing the code. And I love it. So that's going to do it for today's stream. Thanks so much for watching. Hope everybody has an amazing rest of the day and rest of your week. And we will see you next time.